This lecture is for PSY 328, Cognitive Psychology, and in this lecture we are going to review the introduction and the history of cognitive psychology, and this is for week 1 for the CBU Introduction to Cognitive Psychology class. So to begin with, cognition is a very complex human phenomenon, and so it involves things like perception, how we attend or perceive the stimuli and the experiences in our environment, and our relationships and our behaviors. So it highly involves the processes related to perception. It also involves aspects of attention. What things in our environment, stimuli and other things, are we attending to, paying attention to? What things are being ignored? How does that process happen? How does our brain and how does our mind influence our ability to pay attention? Now, think about driving the car, for example, and all the stimuli that are involved in that process. And it's important to pay attention or attend to certain things like red lights, especially in cars in front of us, and ignore other stimuli that may cause us problems or even potentially put our lives in danger. Memory is another important aspect of cognition, how people learn things, how people memorize things and retain that information and then retrieve that information, because it's important to be able to respond and interact with our environment using our memory. How we represent knowledge and store it is another component to this. Language is a huge dimension of cognitive psychology. How people learn language, where is it stored, is it an innate human function, is the brain hardwired to learn language, or do people just have a blank slate kind of ability to learn language, and you just learn the language of your culture. Problem solving, application of knowledge to real-world issues, situations, challenges are another important part of cognition. And then reasoning and decision making. All right, on all of these aspects of cognition include hidden processes of which we may be not aware. So the thing to remember in cognitive psychology is that it is most closely connected to the study of the mind in psychology, which is fascinating. And so here in cognitive psychology, we will experience this mind-brain problem again and again and again. That is, how do our brain structures impact our mind? Currently, we're looking at neuroscience is another important component of cognition and how that plays itself out, and how scientists understand the role the brain plays in cognition and in the mind. And so throughout the course, it's important to think about what we as people, as psychologists, believe about the mind, and then what does the literature say? What are the formal psychological components of the mind? And this will come up later, even in this lecture, when we get into Watson and his relationship with some of the early cognitive psychologists. So some questions to experience. Is cognitive psychology relevant to everyday experience? Are there practical applications of cognitive psychology? Is it possible to study the inner workings of the mind, especially when we can't see the mind or experience the mind directly? And what is the connection between computers and the study of the mind? What is their connection? How does the connection work? Is the computer metaphor a valid heuristic in terms of our understanding of the mind? So now we're going to turn to some early cognitive psychologists. So Donders was one of the first cognitive psychologists, and he studied what we can think of as mental chronometry. And so what he did was he measured how long a cognitive process takes, and this is known as a reaction time experiment. And so what Donders did was he would measure the interval between a stimulus presentation and the person's response to the stimulus. So it's a reaction time experiment. And so there's a simple reaction time task where the participant pushes a button quickly after a light appears, right? And so you measure the time between the attentiveness and the perception of the light and then the person's response. And there's a choice reaction time task where the participant pushes one button if the light is on the right side and a different button if it is on the left side. And so we still use these reaction time tasks currently, although they're a little bit more sophisticated now, but these are really early tasks that computers can aid us to study. And Donders, back in 1868, was connecting the time it takes to respond to a stimulus to a mental process. And so this was a very, very early empirical measurement associated with cognitive psychology. And so in this caption, we can see a modern version of this reaction time experiment where the person observes the light, then pushes a key, press J when the light goes on when the light goes on, and then press J for left and K for right. And so we're also in the choice reaction time connecting into components of memory. Can the person recall the directions and what they're supposed to do and to complete the task? And so it's a very fascinating way to measure mind, measure this cognitive process. And so we can think about a formula here is the choice reaction time minus the simple reaction time equals the time to make a decision. And so, right, the person is faced with the choice, and you can have an absolute time to make a decision in terms of how long it takes. And so, based on this formula, the choice reaction time is 1/10 of a second longer than simple reaction time, and therefore that would mean that the time to make a decision is 1/10 of a second. 1/10 of a second. Now, the issue with this, or something to think about, is that that's a very simple choice. Right or left, pushing those buttons on a keyboard, as compared to, say, do I get married? Do I, some other kinds of more complicated choices. And so in a simple task, responding to a light presentation, that's part of it. And so this would be very relevant to a very confined or specific environment. But it's an interesting thing to think about in terms of, it takes us 1/10 of a second longer to process information to make a choice, as opposed to just respond to the environment. And so, specifically, mental responses cannot be measured directly. However, we can infer their existence based on the participant's behavior. We can't see the process, of course, but there is something going on as evidence between the difference in time between the choice reaction time experiment and the simple reaction time experiment. Helmholtz developed this idea of an unconscious inference. So some of our perceptions are the result of unconscious assumptions we make about the environment, and we infer much of what we don't know about the world. And so we can think about how this is a top-down processing model where we are filling in the content about our environments. And some of this is based on what we know about vision and how our visual fields aren't complete, but they are filled in through the top-down processes of our brains and our minds in terms of processing information. Ebbinghaus was another first cognitive psychologist, and he read a list of nonsense syllables aloud many times to determine the number of repetitions necessary to repeat the list without errors. And so he created a memory drum that would present these syllables that he would be looking at memorizing. And so after some time, and that varied for Ebbinghaus, he would vary that, he relearned the list. And so, of course, short intervals were equal to fewer repetitions to learn. That is, so once you'd learn the list, if there was a shorter period of time between the learning of the list and then the relearning of the list, there were fewer repetitions needed. And so you can learn many different lists at many different retention levels. And so Ebbinghaus plotted this in terms of understanding these initial repetitions minus the learning repetitions, so the first exposure to the list and minus the relearning of the repetitions, all over initial repetitions times 100, and it gave you a percentage of savings of learning over time. And so what he did is he was able to plot this over time. And what we see here is there are significant drop-offs between 19 minutes and 6 days in terms of relearning or savings method, percent savings. There was a 15% drop-off between 19 minutes and an hour. But between 2 days and 31 days, we can see that there are very little variations over time based on this. And so this is an important way. It's a different way between using the reaction time experiments versus this memory experiment to measure an invisible cognitive process empirically. And so the application of science, but a different kind of method to develop this notion of memory and its role in cognitive psychology. And so both of these individuals are very important. These methods are very important today in terms of approaching the notion of the mind. I can't overstate the importance of Wilhelm Wundt to modern psychology. He is the first person to have his own psychology lab, University of Leipzig in Germany. He used reaction time experiments, and he's the father of scientific psychology in the West. And so he's a very important person, and we'll be talking about throughout many of your psychology programs as courses. And so his approach was known as structuralism, which means that one's experience is determined by combining the elements of the experience called sensation. And so what he did was he trained people in analytic introspection. So his participants were trained in how to break apart their subjective experiences and how they responded to stimuli, and then he would map these experiences and their components to come up with the combined complete structure of the experience. And so for Wundt, the focus on the experience connected with the reaction time component was how the human combined or collectively or created their own experiences. And so again, this notion is the study of an unconscious or hidden or unobservable human experience and related to the mind. And so Wundt and the others are all, Ebbinghaus and Donningham, are all very important to the study of the mind, not the study of the brain. It's important to remember that distinction, especially now that we turn to John Watson, who would say that there's extreme variability from person to person, especially using these reaction time experiments and other kinds of structural or introspective methods. And so what Watson took this to mean is that it's hard to identify invisible inner mental processes. Do we need to assume that there's an inner mental process when we can explain, looking at stimulus and responses, behavior? And so Watson was the founder of behaviorism in psychology, and so his approach was to remove the mind from the equation. Why would we assume it exists, especially when we can't verify the results and we're assuming the existence of this invisible construct of mind? And so as a result, he eliminates the mind as a topic of study, and we only need to scientifically study direct observable behavior. And so one of the things that Watson did was he had an experiment called that has become known as the Little Albert experiment. And so what Watson did is he paired an unconditioned response, fear of a loud noise, with a bunny, a small brown bunny. And you can view these Watson Little Albert experiments now on YouTube. They're in black and white, and you can just go to YouTube and search for the Little Albert experiments. And what happened was is Watson took this 9-month-old infant, and there was an experimenter behind the infant, out of the infant's awareness, unable to be seen by the infant, and a little bunny would be introduced in the beginning, and of course the soft plush bunny was not a fear response to the child. But the experimenter would then take the bunny away, introduce it again, and then at the same time make a loud, startling noise that would create fear. And so this fear response was then paired with this bunny. And so then later on, all that would be needed to generate the fear response was the presentation of this brown rabbit. And so it's really an interesting experiment. Of course, now given our ethics review boards for human experimentation, this experiment would unlikely be used, harming a little child. And so this little Albert experiment has profoundly shaped psychology. And the point is that we don't need to assume the mind or some kind of psychodynamic notion of phobia where we can explain this connection of a fear response and this non-fearful plush toy pairing, using this notion of classical conditioning. And so Watson said we don't need the mind to assume these things. And so we can, in terms of classical conditioning, we can pair a neutral event with any event that naturally produces some outcome. And so after many pairings, the neutral event will now produce the outcome. Right? And so the classic one is the related to classical conditioning is Pavlov's dog, where a bell is paired with food, and so of course initially only the presentation of the food caused the dog to salivate, but after a number of pairings of bell and food, the bell alone caused salivation. And so this principle is called classical conditioning, and it forms the basis of Watson's Little Albert experiment, where we can generate a phobic response by pairing a fear response with a neutral stimulus. And so this created the rise of behaviorism. It is very empirical. We can observe, count. Many people can agree, yeah, these things are actually the behaviors that we're interested in, and so we can actually pair or study these things scientifically without assuming that the mind exists, right? We can analyze behavior without any reference necessarily to the mind by using conditioning kinds of explanations. And then B.F. Skinner developed this notion of conditioning further with his understanding of operant conditioning, or how behavior is shaped by rewards and punishment. And so behavior is rewarded is more likely to repeat it, and behavior that is punished is less likely to be repeated. So we don't even need the mind. We can look at how humans reinforce one another by rewarding certain behaviors or punishing other behaviors, and how those patterns of reward and punishment shape interactions from the lowest animal all the way up to humans. And so we can see in this timeline Donner's reaction time experiment all the way through Wundt and then Ebbinghaus. And then a classic text is this notion of William James' Principles of Psychology, which was a more philosophical treatise on the mind. And so these psychologists were all very much in favor of the notion of the mind and cognition. And then we move into Watson and Skinner, who were much more concerned with removing inobservable phenomena like the mind from scientific formal psychology, and using more empirical, verifiable, quantifiable methods to study human behavior and what they would call reinforcement patterns, and not even assume that the mind exists. And so over time, people began to think about, what is this notion of language and how people learn languages. And so in 1957, B.F. Skinner argued that children learn language through operant conditioning. Children imitate the speech they hear, and correct speech is rewarded and reinforced. And so over time, looking at the context that people live in, it's not because that there is an innate ability, of the human animal to learn language or a specific language, it's shaped through the context and the community in which the individual lives. However, Noam Chomsky said that that's not true. Children do not only learn language through imitation and reinforcement. Children say things they have never heard and cannot be imitated. In terms of their identification and apprehension of language and the naming of things. And so in terms of Skinner, it's like learning to play. The metaphor is that it's learning language by observation is like learning to play chess, chess with the kings and the queens and all the various pieces there, a white team and a black team, and not knowing the rules, and every third move is wrong. Right? So if you think about your daily use of language, we make lots of mistakes. There are pronunciation problems, grammatical errors, things of that nature, and people use language despite that. And the use of children and how they are able to do language and learn language based on words and experiences they haven't had. So Chomsky argued that there is a language acquisition device built into the human mind, not the brain, the mind, and so that individuals inherently learn language through this language acquisition device. And there is a complex connection between this innate biological notion of the LAD, the language acquisition device, and then how that is shaped by the culture that the person finds themselves in terms of type of language, subject, verb, object, verb, subject, those kinds of things, and the other specifics related to a specific language. Also, we can look at this article, The Misbehavior Organisms, and how there are attempts to condition animals that did not work. And that is that scientists were attempting to condition out or connect responses to stimuli and pair them with other kinds of neutral stimuli that didn't work. And so this misbehavioral organisms really challenged the overall efficacy and effectiveness of conditioning, especially connected to this notion of something that's innate or instinctual in animal behavior. And further, there was this researcher named Tolman who trained rats to find food in a four-armed maze. And so the issue is that the behaviorist would say that the rat would learn to find the food by pairing the correct pathway to getting the food. And so they would turn right to find food, and that turning right would be paired with the reward of food. However, if you pick the rat up and you put it in a different part of the maze, the behaviorist would assume that the rat would have to relearn how to get there, and that turning left, for example, to get the food would be the rewarded behavior eventually. However, what Tolman discovered was that the rats were able to have a cognitive representation of the map, and therefore they were able to get to the food quicker, right? And so they were able to navigate to the specific arm where they previously found food. And this supported Tolman's interpretation, and it did not support behaviorism interpretation, where no matter where the rat would be placed in the maze, they would have an equal time to get to the food, whereas the rat that was put in one arm first and learned the maze would be taken to another part of the maze and put down, had a quicker time to get the food. And so that notion is that then the rat had some kind of cognitive memory or representation of the map where the food was that allowed them to navigate it faster, which was against behaviorism's interpretation. And so this caption provides us with a representation of the Tolman experiments. And so to understand complex cognitive behaviors, we need to have measurable, observable behavior, uh, um, clicking left or right on a keyboard, and then we use that observable behavior to make inferences about cognitive activity. And so what does this mean about the way the mind works? And so that is a core question about cognitive psychology and trying to understand how things work and what it means for cognition and the mind. Right? And so the cognitive revolution begins to happen, and this creates or generates a shift from the behavior stimulus response understanding to an approach that attempts to explain behavior in terms of the mind. Right? So it's not a simple stimulus response or even a classical or operant conditioning understanding of shaping behavior through reinforcement patterns or punishment patterns. It is a complex interaction between the human animal using the mind and the environment, what things are attended to, how things are perceived, memory components, what are the instructions or what are the important components that we need to engage with there, and then what filters are applied and how those things are used to understand how humans interact with the environment. And so we can understand how, as the computer was invented and developed, that information processing begins to have a huge impact on the cognitive revolution. And so this information processing approach becomes a way to study the mind from insights associated with the computer. And so we can see here that a very simple flow diagram for an early computer is that there is some input. The input is processed in some manner, sent to a memory unit, and then sent to an arithmetic unit, right? Because in the computer, it is a binary, especially the early ones, zeros and ones kind of a notion, based on the input and how it's processed, the instructions given to the into the memory, how these are coded arithmetically, and then the output happens. And so now, or a more developed notion based on Broadbent's model is that there are many inputs sent. These inputs are filtered and through the mind, and then one salient input is identified through the detector, and this is sent to memory. Right? And so early computers processed information in stages, and so an early understanding is how much information can the mind absorb, and how do we attend to just some of the incoming information. You know, what is filtered out, what is filtered in, and how do we understand that, and how do we study that. And so Cherry proposed this notion of dichotic listening, and so a message is presented in the left ear, a message is presented, B, in the right ear. And so to ensure attention, we shadow one message. And so participants in this experiment were only able to focus on the message they were shadowing or attending to. And so the other side, the other message would be filtered out or become background noise. For Broadbent, this flow diagram represents what happens is one person directs attention to one stimulus, and unintended information does not pass through the filter, it is ignored. And so people attend to based on some filter, cognitive filter, what is most salient in a given situation. And so this figure 1.12 presents the timeline. Right? So Cherry begins an attention experiment. In 1954, first commercial computer is made. MIT and Dartmouth conferences happen. 1958, Broadbent develops his flow diagram. Right, and so then 59, some of the discussion about learning and language acquisition device in against B.F. Skinner's verbal behavior and how he argued about how humans acquire language. And then Neiser publishes the first cognitive psychology textbook. Right. And so some methods to researching the mind are using a behavioral approach which measures the relationship between stimuli and a behavior, Right? Included in that would be the perception of the behavior, how we attend to that stimulus in our environment, assuming things about the cognitive filter, the memory part in terms of understanding or remembering the directions about responding to the stimuli, and then the specific behavior that one is supposed to engage in. And of course, physiological approaches would be connecting the physiology of the brain and the behavior, and how how we understand the processes or the components of the brain and how they relate to our perception, attention, memory, and then how those things go about or result in the person's behavior. And so both of these are important scientific, observable ways that we understand and study cognition. Memory consolidation is another important component of this, and so memory for recent events is more fragile. If the processing is disrupted, recent memories can fail to be consolidated, and therefore we can have difficulties in recalling them, and so this new information can, of course, interfere with memory consolidation. And so it's more of a behavioral approach. Muller and Pilzecker had participants learn 2 lists of words, and the independent variable in their experiment was that one group learned the second list immediately after the first. The other group experienced a 6-minute delay between learning the lists, right? And so the exposure to the second list is the independent variable, right? And so immediately after the second list is presented for one group, 6-minute delay for the other group, and memory of the first list of words is the measurement of the dependent variable. And what they found is that the people that had the delay were much better able to recall the list, right? So there is a one list presented to a 2 list, no delay, and these individuals had a 28% recall rate, and a delay of 6 minutes jumped the memory to 48%. And so Gaius studied the effect of sleep on memory consolidation. So in this experiment, the independent variable was learning a list of words shortly before going to sleep. And the other group learned a list many hours before going to sleep. And so memory, or actually forgetting of the list of words, was measured 2 days later. And so what this researcher found out, that the people that tried to learn the list before they went to sleep forgot much more of the list than the awake group. Right? And so we can see here that trying to memorize things right before sleep was very counterproductive to memorizing the results. There might be an application there to your final exams, and I'll leave that for you to decide. Right? And so what we can also use is a physiological approach, and use functional magnetic resonance imaging, or MRIs, or functional MRIs in this case, to understand and to see what parts of the brain are active when we encode or consolidate memory and then recall that. And so what the results of the study from Gaius found is that there are differential brain activities between the two groups. All of this emphasizes that cognitive psychology or cognitive science is a very, very interdisciplinary study. There are psychological components, there are computer science components, there are aspects of cognitive anthropology, linguistics, neuroscience, and of course philosophy. And so cognitive psychology or cognitive science is a very interdisciplinary and integrative cutting-edge line of research or dimension of psychology, and we're trying to find ways to study and understand the inner workings of the mind. And so, in my perspective, cognitive psychology is one of the most interesting and important aspects of modern psychology, especially related to this notion of the mind and its existence, its tension, where some people are arguing for a more physicalistic brain understanding, and there are others on the other side of the spectrum that are studying the mind. And so this course is going to actually lay out the groundwork for this tension. We will introduce some of the main classical experiments associated with cognitive psychology. And over the course, we'll be able to discuss this through the threaded discussions, through the assignments, and other kinds of things. So this concludes our Introduction to Cognitive Psychology lecture. Please feel free to email me and to discuss any questions, concerns, comments. And I thank you for your attention to this lecture.